Now we will incorporate concepts of differentiation and integration in kinematics. So if you want to get velocity and you have your displacement, you will differentiate your displacement to get your velocity. So your v is equals to your ds dt. And then you have your velocity, you want to get your acceleration. You will differentiate your velocity. So dv over dt will give you your a. This also means that your acceleration is also equals to d2s dt squared, meaning you differentiate your s, your displacement, 2 times. So since integration is basically the opposite of differentiation, we can integrate our acceleration to get our velocity, so we are going backwards. If we integrate acceleration, we get velocity, and if we integrate velocity, we'll get back our displacement, our s. Now some terminologies we can recognize and know what concepts to apply when we see them in the questions. If the question asks for initial displacement, velocity or acceleration, so basically initial anything, we will sub t equals to 0 in our expression. So t basically just represents our time. So time equals to 0 is when we are at our initial point. And then if the question asks for t seconds after passing fixed point O, we will sub in t equals to 0 and s equals to 0. When we draw a line and we have our fixed point O here, so we are passing fixed point O, and only after we pass our fixed point O, then the t will start to increase. Therefore, when the particle just passes our fixed point O, t will be at 0, and our displacement with respect to this fixed point will also be 0. That's why s is also equals to 0. So we usually sub t equals to 0, s equals to 0 to find the arbitrary constancy when we integrate v to get our s, our displacement. So when you integrate v, with respect to t, you usually get something t plus something blah blah plus c. So this c that we get at the back after integrating, we need to find it, and we'll find it by subbing in t equals to 0 and s equals to 0. Next part, we have displacement and distance after our particle makes a turn. So let's say our particle starts at point O. So here, it is instantaneously at rest when t equals to 1. So if you recall, instantaneously at rest means that there's a change in direction. And then the question asks us to find the displacement for the first 4 seconds. First step, we will find our displacement when t equals to 1. So this is when our particle changes direction. So we need to find the displacement when it changes direction. So we'll get s equals to 5 meters. So this just means that the particle will travel 5 meters before it changes direction, so until here. Next, we need to find our displacement when t equals to 4. So basically, after 4 seconds, what is the displacement of our particle with respect to our fixed point O, which we'll get s equals to 3 meters. So after we have this information, then we can draw the particle path. So let's say we have a fixed point O here. We will know that it travels 5 meters before it starts to change direction. So here is when t equals to 1. So here is when it changes direction. Then since our displacement at the end of 4 seconds is closer to fixed point O as compared to when it changes direction, we'll know that it's turning backwards. So we'll go back until it is 3 meters away. So until it's 3 meters away from fixed point O. So since the total length is 5 meters, it is 3 meters away from fixed point O, we'll know that this distance is 2 meters. So it turns back and travels 2 more meters. Now we can find our total distance traveled. So it's just this length plus this length. which is 5 plus 2 equals to 7 meters. And next part, if the particle changes direction twice, so it turns twice, it is given that when v equals to 0, t equals to 1 second or 4 seconds. So when v equals to 0, this is when it is instantaneously at rest, which is also known as particle changing directions. So you must be able to recognize all these hints that the question is giving you. So when v equals to 0, t equals to 1 or 4, this means that the particle changes direction at t equals to 1 and t equals to 4. That's why it changes direction here and here. So we need to find the total distance traveled in the first 6 seconds. Since we are only given our velocity, to get our displacement from velocity, we refer back here, it is the integration of our velocity, our v. Therefore, first step, we will find the expression of s by integrating v. Secondly, we will find s when t equals to 0. So whenever we find s, firstly, find s at the starting point. So when t equals to 0. Secondly, we'll need to find s at the direction changes. Thirdly, we will need to find s at the end. So where it ends up after 6 seconds. So to find at the start is when t equals to 0. We'll sub t equals to 0 into the expression of s. In order to find the s for direction changes, we'll sub t equals to 1, t equals to 4, because that's when we have a direction change. And then finally, to find the displacement at the end, it's just however long that the question wanted us to find for. So 6 seconds. That's why we'll sub in t equals to 6. And then we'll get all our values here. So now we can draw the particle path. It will start at 0, so a fixed point of O, and then it will travel 11 meters. Before it first changes direction at t equals to 1. So we get our 11 meters from subbing in t equals to 1 into our s. Afterwards, we'll continue drawing the particle path backwards until we reach s equals to negative 16. So this negative 16 is with respect to our initial fixed point O. So means it is 16 meters behind fixed point O, which is not equivalent to traveling 16 meters only. This part will be your 16 meters, not the entire length. So here at t equals to 4, it changes direction again. So around here is when t equals to 4. And finally, when t equals to 6, s equals to 36. So this 36 is also with respect to fixed point O. That means you will travel all the way and end up somewhere here. And your 36 meters is this length, not this entire length. That's wrong. This 36 meters is from fixed point O all the way to where it ends. So this 36, and here is where t equals to 6. So now the total distance will be this whole length. So it will be 11 plus this length that it turns back. So another 11 plus 16, this extra length here until t equals to 4, plus another 16 because it turns back around here. And then plus your final length of 36 all the way to the end, which will give you a total of 90 meters. That's how you get this 90 meters over here. So example 16.2i, a particle starts at a point 5 meters away from our fixed point O. This means that when t equals to 0, our displacement s equals to 5. So along the way, when you read through the questions, if you see any hints that the question gives you, you can immediately write down what it means. So you can annotate the question. It travels in a straight line so that its velocity is given by this expression, where t is the time in seconds measured from the start of the motion. Firstly, calculate its acceleration when t equals to 2. So right now we have our velocity, our v expression. To get acceleration from velocity, we will differentiate it. So dv dt. That's how we will get our a expression by differentiating our v, which will get 6 minus 6t. Afterwards, the question specified when t equals to 2. So we'll sub in t equals to 2 into our acceleration expression. And then it will give us negative 6 meters per second squared. Okay, part 2. Find the time when the particle is momentarily at rest. Momentarily at rest is also equivalent to instantaneously at rest. And then this is a keyword they have to be able to identify that they're trying to tell you to sub v equals to 0. So your velocity is equals to 0. That's why here you will let v equals to 0, and then let the expression of v equals to 0. You will factorize out 3t. So 3t will be outside the bracket. Then inside the bracket, you'll be left with 2 minus t equals to 0. Afterwards, you will get 3t equals to 0 or 2 minus t equals to 0. Therefore, you will end up with t equals to 0 or t equals to 2. Part 3. The maximum velocity attained by the particle. So maximum velocity, you have to think of maximum point, finding the maximum point. And how can you do that? You can find that through your differentiation techniques. So your applications of differentiation, you have learned that to get maximum point or minimum point, so these are any kinds of your turning points. In order to find that, you will let your differentiated, so maybe in this case dy dx, you will let that equals to 0. Therefore, in order to find your maximum velocity, you will differentiate your velocity and let it equals to 0. So your dv dt is 6 minus 6t. Then you let it equals to 0. Then you shift the 6t over and divide both sides by 6. You will get t equals to 1. Now we cannot stop there because they asked for specifically the maximum velocity. Now we've only found the t equals to 1. So that is our time. We need to sub it back into our expression of our velocity. That's why we sub t equals to 1 into our v, which will give us 3. That's why our maximum velocity will be equals to 3 meters per second. Part 4. The distance of P from O when it comes to instantaneous rest. So firstly, distance, you immediately think of your displacement, so your S. When it comes to instantaneous rest. Instantaneous rest, once again, you have to think of your V equals to 0. So in part 4, we'll be required to find our expression for S. In order to do so, we will, being given only our velocity expression, to get our S from our V, you'll need to integrate your V with respect to t. That's why here, we will now integrate 6t minus 3t squared to get 3t squared minus t cubed plus c. So this is what we meant previously when you will sub in your t and your s to find your arbitrary constant c. Remember at the start of the question, we identified that when t equals to 0, s equals to 5. this is what we'll be subbing into our expression to find our c. So we'll sub in here t equals to 0, s equals to 5, and then you'll find that our c is just equals to 5. So putting that into your s expression, you'll get 3t squared minus t cubed plus 5. Then now we need to go back to the question and check for what specifically it wants. It wants a distance of p from O when it comes to instantaneous rest. What are the values of t when the particle is at instantaneous rest? Firstly, you have your t equals to 0. And secondly, you have your t equals to 2. So this is your part 2 answers. Therefore, you will sub in your t equals to 0 and your t equals to 2 to find your s, which is s equals to 5 and s equals to 9. For the final part, the question wants you to find the total distance traveled by p in the first 3 seconds. So when you're trying to find the total distance, step 1 is to find your s at 3 different points. Firstly, at the very start, where t equals to 0. Secondly, is at points where you change directions. So from your part 2, you can see that when v equals to 0, t equals to 0 or t equals to 2. So since t equals to 0 is your starting point, the change of direction will occur at t equals to 2. And finally, at the end. So since the question wants us to find the first 3 seconds, then the end point will be when t equals to 3. So you sub all these t values into your s, and you will end up with these 3 values. So s equals to 5, 9, and 5 again. Then afterwards, you'll be able to map out the path that your particle took. You will start off with your fixed point O. From the question, we know that the particle starts at a point 5 meters away from fixed point O. So this fixed point O is not where t equals to 0. T equals to 0 is actually here, 5 meters away from fixed point O. So t equals to 0 is here, and then the particle will start traveling until here. This is where it changes direction, so t equals to 2. So at t equals to 2, s equals to 9. Now this 9 is with respect to your fixed point 0. So this 9 is not this highlighted part. The 9 is actually this entire highlighted part, because it must start from your fixed point 0. So since this entire length is 9 meters, here's a different color. Since this entire length is 9 meters, this length will be 9 minus 5 meters, so 4 meters. Then now, after it change direction, it will go backwards until s equals to 5. So this is where t equals to 3. Since s equals to 5 again, this means that the particle is 5 meters away from your fixed point O again. So this is your 5 meters. Therefore, the distance that's actually traveled from t equals to 2 to t equals to 3 equals to your 4 meters. So the total distance will be 4 meters plus 4 meters, which is equals to 8 meters.